This question was asked in GATE 2017 Electronics and Communication Engineering paper set 1, in which you have given two statements on continuous time LTI system, and you need to find out which one among the following is correct. So the NPTEL reference for this question is Principle of Signal and System by Professor Aditya Jagannatham. You can find reference in the lecture, which is Properties and Analysis of LTI System Part 2. So the useful data for this question is that for a causal system, the ROC should be right to its pole, and for anti-causal, ROC should be left to its pole. Suppose if it is your complex S plane, then for a causal system, its ROC should be right to its pole. So it is ROC for causal system, and left to its pole should be the ROC if the system is anti-causal. Now, this is the first useful data for this question, and the second useful data for this question: for a stable system, ROC should contain J omega axis. Then it will be a stable system. Now, coming to the solution, you have given the first option is there is no bistable, that is bounded input, bounded output, stable system when a pole lies in right half of complex plane. So this is the statement you have given. So let's suppose if the pole is in the right half of the complex plane. So you are saying the statement is saying that there is no bistable system when a pole lies in the right half of the complex plane. So if the pole lies in the right half of S plane, and suppose if it is anti-causal, suppose if system is anti-causal, then the ROC of this system should be left to its pole. So it contains J omega axis, that is your J omega axis. So it contains J omega axis. So it will be stable but anti-causal system. So this statement is not correct. However, the second statement is given as there is no causal and bistable system if a pole lies in right half of complex plane. So this statement is correct because let's suppose if you have a pole in the right half of the complex plane, then if it is causal, then the ROC should be right to its pole. So it is not containing J omega axis, so it is unstable. But if it is anti-causal, then it will contain J omega axis, then it will be stable but anti-causal. So the condition is there is no causal and bistable. So yes, it is correct because there is no causal and bistable system if the pole lies in the right half of the complex plane, because if it is causal, then it will be unstable system, and if it is anti-causal, then it will be stable. So the two conditions will not meet at one time. So the correct answer for this question is option D, only 2 is true.